Ladies and gentlemen, good morning. A very warm greetings to each and every one of you. Welcome to the 2023 International Conference for Healthy Aging and Biomarkers, hosted by the National Center for Geriatrics and Welfare Research, National Health Research Institute. I'm your host today, very glad to be at your service, always. Yesterday, we witnessed fruitful dialogues from scientists and scholars from Canada, Japan, Singapore, the US, and Taiwan. Today, we gather together to further listen and learn about identifying the biomarkers for understanding the aging trajectory. Please join me in welcoming Professor Chen Weijian and Professor Hong Jianqing to the podium to chair the morning session. Professor Chen is the Vice President of the National Health Research Institute of Taiwan and also serves as the Director of the Center of Neuropsychiatry Research. Professor Hong is the Vice Superintendent at the National Taiwan University Hospital, Yunlin Branch. We are honored to have them chair this session. Let's welcome Professor Chen and Professor Hong.
Good morning. I hope our distinguished guests have a very good sleep last night after a very delicious dinner. So welcome back to the second day of this conference. And this morning, we have 4 speakers, and I will introduce the first 2, and Vice Superintendent Hong will introduce the 3rd and 4th speaker. So our first speaker is Professor Zhang Wang. Professor Wang got his medical degree from Seoul National University and then got the PhD from Korea University. And he has been professor at the Department of Family Medicine at Kyunghee University School of Medicine, and then become the head of the department since 2012. And now he is the president of Korean Society of Sarcopenia. So today he will share with us about healthy aging and biomarkers, from solitary biomarker to combined biomarkers, experiences from KFACS Cohort study. So now let's welcome Professor Wang.
Thank you. Thank you. It works. May I move to center? Okay. And, from my experience from KFACS Cohort, which I've been working on, I will talk about some biomarkers for especially frailty and sarcopenia, and also some combination of biomarker study. So I will touch some my KFACS study. After then, I'll talk about biomarkers of sarcopenia and some multi-omics experience, and for frailty, and lastly, multi-biomarker risk score. I mean, combination of multi-biomarkers. So Korean Frailty Aging Cohort Study, KFACS, is a cohort which I've been working on. This is a symbol, the throwaway cane. So my wife painted for me, free, it's free. And so KFACS, we think about facsimile. I think you don't forget that. Young guys don't know facsimile, but old guys know that. So KFACS, we recruit older adults who are community dwelling or elderly from across the nationwide. So from 10 centers, including Jeju Island, we recruit community dwelling elderly. So we start in 2016 and 2017 as a baseline study. And we've been working on we do a follow-up every 2 years. So I'll talk about biomarkers. So in terms of muscle growth, you know that BDNF or follistatin is increasing muscle mass. But, and you know that myostatin and GDF15 is suppressing muscle mass. So this is myostatin. So as I told you, as you know, myostatin suppress muscle mass. So it increases muscle mass functionally. But if you measure blood level of myostatin, if the myostatin level is high, what do you expect with muscle mass? Muscle mass may be low or high. It must be low, right? Because it functions as a suppressing muscle mass. But the result is the reverse. I mean, with the higher level myostatin level, the muscle mass is higher. It's a kind of paradox. So when you analyze this data, we found that muscle mass and myostatin positive relationship. So sometimes we stop here. Oh, negative finding. So it's a bad finding. So, but actually, that is the reality. That is real. So this is my study result. So why? I think if muscle mass increasing, this is myostatin is myokine, so it's secreted from muscle. So as a negative biofeedback, it may be secreted. So muscle mass increasing, myostatin secreted for negative feedback is my guess. So I think about how about myostatin and skeletal muscle mass ratio divided by muscle mass. So in 1 unit of muscle mass, how much is the myostatin level? So look at analyze with the muscle mass, okay, hand grip strength. So we found that highest quartile group of myostatin ASM ratio had the lowest ASM index. And especially the highest group had the lowest grip strength. So if we have a ratio, the result is reasonable. This kind of paradox result can be found in other study, in other articles. This is done by Peggy Cotton, you know. They look at a cross-sectional study with two large cohort study, Health ABC and CHS. And that they found that myostatin, GDF8, myostatin level is positively associated with muscle mass, not negative. And you know, follistatin is a good one, increasing muscle mass functionally, but the blood level of follistatin was negatively associated with muscle mass and muscle strength. So it's a kind of paradox, but I think it's a kind of feedback reaction. So it's kind of another paradox, FGF12-1. So this is my KFACS cohort data study. That is fibroblast growth factor 21. It's good for, obesity or diabetes. So it functions as an anti-inflammatory, anti-diabetic, anti-obesity. But the function is that, but the level, circulating level, blood level of FGF12-1 also associated with obesity and type 2 diabetes. Functionally it's good, but blood level, higher level of FGF21 is also associated with diabetes and obesity. Do you understand? So our study group showed that also So we think that FGF12-1 may be good for muscle mass. But the result, the blood level of FGF12-1 associated with low hand grip strength and higher prevalent sarcopenia. So again, I think it is kind of compensatory biofeedback mechanism. How about GDF15? GDF15 is not myokine, but so it is not confusing. It's really bad for muscle. It's known as a macrophage inhibitory cytokine. So after adjusting for confounders, it's a KFACS Cohort data. So highest GDF15 total was associated with increased sarcopenia prevalence, as you see here. So cross-sectionally, GDF15 is a marker of sarcopenia. But unfortunately, when you look at two-year follow-up data, elevated GD15 was not able to predict instant sarcopenia. If we follow up 4 years, 6 years, though, we may find positive finding, but for 2 years, we didn't find any result. Instead, I think GD15 may be more associated with cachexia rather than sarcopenia, because GD15 suppress brainstem appetite center. So it increases anorexia and it decreases muscle mass, fat mass. So I know that some pharmaceutical is developing medicines for treating anorexia, especially for cancer patients, cachexia. This is also from our KFACS Cohort study. It's about P3MP. It's a pro-collagen type 3 N-terminal peptide. P3MP is a collagen derivative. So P3MP is released into blood during collagen fiber degeneration. It's not about muscle, but when you look at the relationship with physical performance, we found that in cross-sectional study, higher level of P3MP was associated with negative, P3MP was inversely associated with physical performance, like SPBB and 5-time chest stand test, but not associated with muscle mass in our study. So biomarker P3MP may be kind of marker for muscle quality, not muscle mass. So it is another study, Chianti study from Italy. They showed similar result. They followed 3 years, 6 years later, and they found that P3MP was associated with muscle density decrease. So higher level of P3MP is associated with decrease in muscle density and poor physical performance after 3 years, 6 years later. So as you see here, muscle density and SPBB. So they say that it may be related with fatty infiltration, muscle fat infiltration, or fibrosis. So it's good for it's a marker. It could be a marker for muscle quality, muscle function. And also we look at the biomarkers based on serum creatinine and cystatin. As you know, creatinine is a marker for muscle mass and also kidney function. And cystatin is only for kidney function. So if you look at the ratio, it means it can be some biomarker of muscle mass. We found 5 index using creatinine and cystatin C. That is the ratio between creatinine to cystatin C. And the second one is sarcopenia index. That is serum creatinine multiplied by GFR using creatinine. Cystatin C. And third one is the ratio between GFR using cystatin and creatinine. And the first one is using, is a kind of index they're using age, creatinine, cystatin, hemoglobin, and body weight. And similarly, a biochemical total body mass mass index, they are using weight, creatinine, and cystatin, whatever. So out of these 5 index using creatinine and cystatin, we found that the first 3 index is not good to diagnose sarcopenia, but this one, number 4, number 5, is good to diagnose sarcopenia. And also we have some experience in multiomics using metabolite multiomics. So out of the KFACS data, we chose 10 severe sarcopenia, 10 non-sarcopenia. Why just 10 persons? You know, multiomics study is very expensive, very, very expensive, you know. So we chose just 10. And so, and then we did some non-targeted metabolic analysis. And then out of 1,000 metabolites, tentative 1,000 metabolites, 191 metabolites were found in my 10 persons of person's blood. And among them, we found that just four metabolites were significantly different between severe sarcopenia and non-sarcopenia. So this is the result. It showed that a higher level of alanine and proline, glycolic acid, and low tryptophan was a biomarker for severe sarcopenia. So if we have higher alanine, higher proline, higher glycolic acid, it means severe sarcopenia. Or otherwise, low tryptophan may mean severe sarcopenia in my study. So what is the explanation as to proline, alanine? Actually, proline is an essential component of a collagen. It's an amino acid of a collagen. But because it works for joints, and maybe it may work for a muscle. And especially proline and alanine are generated by proteolysis in skeletal muscles in malnourished. Because we don't eat well, muscle breakdown, and then proline and alanine is coming out to blood. And there are some studies that low physical activity and longer sitting is associated with the high level proline. So as you know, when you look at the TCA cycle, proline or alanine is used in this cycle for energy production in mitochondria. So I think that this kind of amino acid is used as a energy production, and also it can work for muscle activity. I found one study. They showed that out of this kind of amino acid, including glutamine, histidine, proline, tryptophan, only after multivariable analysis, they showed that only proline was associated with sarcopenia. So maybe proline is a very important amino acid as a biomarker of sarcopenia. So how about tryptophan? It's very interesting. We heard yesterday about tryptophan. So we must remember that tryptophan itself is a substrate for muscle synthesis, protein synthesis. And also it produces serotonin and melatonin. But it's a healthy condition in this way. But under a stressful condition or with chronic disease, tryptophan metabolized to kynurenine. Very interesting pronunciation. Kynurenine, right? Kynurenine. So it's very toxic material for muscle. So, I mean, tryptophan can be used under, stress condition with chronic disease. It can be bad for muscle, but if not under stressful condition, if not with some chronic disease, it can be used as substrate for muscle mass. So I found one study which showed that tryptophan level is positively associated with growth strength and gait speed. But my assumption is that why tryptophan is good for muscle mass? Yeah, it could be a substrate, but also it can produce serotonin. So it associated with good mood, good sleep, and it may increase muscle mass. So I think it could be another assumption, pathway. And why gluconate is associated with muscle mass sarcopenia? I don't know. So gluconate is produced by oxidation of glucose, as you see here. But the role, the effect is mystery. We don't know yet much about that. But if you are interested in gluconate, I recommend you to study about that. How about biomarkers for frailty? So yesterday, Ochika told us about EPA, DHA level, blood level. But instead, we check the red blood cell level of EPA and DHA. So some say that fatty acid composition of RBC membrane is better than plasma level because it represents more long-term dietary fatty acid, PUFA intake. So it's more stable than just blood level. Anyway, we found that with higher RBC level of EPA and DHA is associated with low risk of frailty. And if we look at the 5 items, the EPA, DHA was not associated with weight loss, or not so much with hand grip strength, but it was associated with exhaustion and gait speed. Yes. So maybe EPA, DHA is good for neurologic, CNS or motor neuron. So that's why it's good for gait speed or exhaustion. And BDNF, it's a marker for neuronal activity, but it is also found in blood. So if we practice exercise, the brain excretes BDNF, and it comes to blood. But also, if we muscle contraction, the muscle produces BDNF also. And BDNF function as an enhancer of lipid oxidation, decreasing muscle fat infiltration. So we found that BDNF is a good biomarker for frailty. Okay, we don't have much time. And we also some study about hypermethylation of gene in related with the premotor region of brain is associated with cognitive aging. And multi-biomarker risk score, because as you know, the sarcopenia, the pathway is very multifactorial, multi-pathway. So just one single biomarker does not explain sarcopenia well. So we tried to, we found 14 biomarkers candidates after searching literature, so these 14 list of candidates, including CRP, myostatin, GDF15, anyway. So with KFACS data, we found that out of that 6 biomarker was not effective, so we excluded that. And finally, 8 biomarkers are left. So with these 8 biomarkers, we made some risk score. So I will skip this one. So everyone is meaningful, I mean. And how to develop multi-biomarker risk score with the 8 biomarkers. So for that, we used rigid regression. I don't know where, but it's a kind of AI. So because we use 8 biomarkers, variables, there are multi-correlated related between variables. It means that if we, without any adjustment, without any control, the score can be more than 10 or more than 1. It must be within 1 to 0, 1 to 10, but due to multicollinearity, without any adjustment, the result will be overfitting. We say that it is overfitting. So we use rigid regression, and the score formula is like this, the final. And the distribution is from 0 to 10. And we found that the best optimum score is 1.76. Anyway, compared to the So when you use the multi-biomarker risk score, it was higher than any single biomarkers. As you see here, the blue one is multi-component risk score, and others are single biomarker. So it's much better. And if you do some stepwise regression study, we found that GDF15 and consistency is starting, and if we're adding more variable, the AUC is becoming much bigger. But I think that out of this combination, GDF15, consistency, DHA, myostatin, hemoglobin, ASALT is best because the sensitivity is 0.83, even though specificity is 0.4, but for screening us, I think it is the best choice of a combination. Okay, thanks so much. And I'd like to give thanks to my KFACS member, especially Miji Kim, the professor, PhD, and also Shin Hyung-hun, my PhD student. They do this kind of wonderful job. And I'm just transferring the results today. I'm just transferring, but it is not easy because I'm not a scientist, but I'll try to express the results. Thanks so much.